Module 7.1. As a reminder, it's recommended to print the video script and annotate the script while watching the video for later use. Video scripts are available on Canvas. Module 7.1. How can we numerically describe quantitative data? In the previous modules, we discussed ways to summarize data. We need to summarize data because saying something useful about raw data can be difficult, if not impossible. Recall there are two ways we are going to classify variables. Categorical variables divide the cases into groups and places each into exactly of one or two or more categories. Quantitative variables measure a numeric quantity for each case. Numerical operations make sense for these variables. Previously, we discussed summarizing categorical data with both descriptive statistics and graphs. Additionally, we looked at graphs for quantitative data. In this module, we will continue looking at quantitative data. Recall, when describing a quantitative variable, we consider the following three questions. What is the general shape of the data? Where are the data values centered? And how do the data vary? To illustrate summary of quantitative variables, let's review the ICU dataset we looked at previously. The ICU dataset consists of a sample of 200 subjects who were part of a much larger study on survival of patients following admission to an adult ICU unit. For this dataset, the cases are each of the subjects. The dataset consists of 20 variables, majority of which are categorical. There are three quantitative variables in the dataset: age, systolic blood pressure, and heart rate. We are going to look at some numerical summaries that will help us describe the dataset. One way to summarize a quantitative variable is look for a measure of center or centrality. A measure of centrality tells us about the center of the values of a quantitative variable. There are many different ways to measure centrality, and you've probably already familiar with some of them. The mean is one of the most commonly used statistical summaries. It's also known as the average. The formula for the mean is given in the video script. The median is another common measure of centrality. To find the median, observations are arranged from smallest to largest. The median is the middle number of the ordered data, if there is an even number of data points, and the median is the average of the two middle numbers if there are an odd number of data points. The mode is the value that occurs the most often. The mode is usually useful if the quantitative variable takes few values. Example, we will look at the variable age in the ICU dataset. Since there are 200 subjects in the dataset, n is equal to 200. The 200 values of the variable age are given in the video script. To calculate the mean, we first want to add all 200 values for the age variable. Adding all the numbers together, we find they add up to 11,509. Next, we divide the 11,509 by the number of subjects, 200. This gives a mean of 57.545. To find the median, we need to arrange the data from smallest to largest. Next, we want to find the middle number of the arranged data. In this case, there is an even number of data points, therefore the median will be the average of the two middle numbers. For the age variable, the two middle numbers are 63 and 63. Therefore, the median is equal to 63. The values which appear most are 55 and 75, each occurring 8 times. Therefore, the mode is equal to 55 and 75. Your turn. Pause the video. Calculate the mean, median, and mode of the following data set of test scores. Round, if necessary, to the nearest tenth. You should have found that the mean is equal to 79.25. The median is equal to 82.5, and the mode is equal to 74 and 86. Which measure of centrality should I use? Notice that the mode in the age example is 55 and 75. These values fall close to the center of the histogram we saw in Module 6. In general, the mode does not give us a good idea of where the center of the dataset is. The mode only tells us the most common values of the variable. These values may or may not fall in the center. For this reason, the two most common measures of centrality are the mean and the median. One advantage the mode does have is that we could use it with categorical data. The choice of whether to use the mean or the median depends on if the data set contains outliers and the shape of the distribution. Outliers are data points that are very large or small compared to most other data points. They are extreme data points. One way to detect outliers is to look at a plot and see if any of the points look extreme compared to the others, or for large gaps in the values. Later we will look at numerical ways to detect outliers. When a data set contains outliers or has non-trivial skewness, the median is typically used as a measure of centrality. When a data set does not contain outliers or is roughly symmetric, the mean is typically used as a measure of centrality. The reason for this is that the mean can be greatly influenced by outliers, whereas the median is not. We say that the mean is sensitive to outliers. Example: 10 people are sitting in a coffee shop. The net worth in thousands of dollars is listed below. The mean of this data set is $18.9 thousand and the median is $19,000. Regarding net worth, there's not much difference in the value of the mean and the median. Also notice that none of the net worth values are extreme compared to the rest. Now let's suppose that Elon Musk, net worth $2.6 billion, walks into the shop. The new data set is as follows. First, notice that Elon Musk net worth is extreme compared to the others. It is an outlier. The mean of this new data set is $181,835,036, and the median is $20,000. Regarding net worth, there is now a considerable difference in the value of the mean and the median. The mean was strongly influenced by the introduction of the outlier, whereas the median did not change much. Additionally, notice that the mean is higher than the net worth of the original 10 people and lower than the net worth of Elon Musk. The mean does not give a good descriptive summary of the net worth of the people in the coffee shop. The median, on the other hand, gives a good summary of the majority of the net worth values. Your turn. A class of kindergartners are playing on the playground. Their teacher walks over to the students. When the teacher joins the students, does the average height or median height of the people on the playground change more? The average height will change more because the teacher's height is an outlier compared to the students.